right, this is lesson 77. It's converting units of mass and weight. So we have two systems. Depending on where you live, you're going to use, if you live in the United States, you're going to use the U.S. customary system. If you live almost anywhere else in the world, you're going to use the metric system. Remember, we're thinking about weight. Now, there's fluid ounces too. Like if you're measuring milk, sometimes you'll see a fluid ounce. This is weight measurements. So 16 ounces is 1 pound. You could write it OZ and LB. 2,000 pounds is 1 ton, and ton is TN. And then in the metric system, my base unit of weight is grams. If I add some prefixes to the word gram, it tells me how many of those I actually have. So 1 milligram, just one, is 1,000th of a gram. But if you have 1,000 of them, it equals 1 gram. So 1,000 milligrams equals 1 gram. If you have 1,000 grams, you have a kilogram. So milli means 1,000th. Kilo means 1,000. Okay, so 1,000 grams equals 1 kilogram. 1,000 kilograms equals 1 metric ton. And that the U.S. customary ton is abbreviated TN. The metric system ton or the metric ton is just T. And it's T with a funny little beautiful curve, which I don't do very well. Okay, so let's talk about how much those really are. 1 slice of bread is 1 ounce, more or less, if it's not that real heavy, dense bread with 12 grains and 15,000 things in it. 1 shoe is about 1 pound, if it's kind of a heavyish shoe. 1 small car is about 1 ton. And then if we go over to the metric system, I find that 1 milligram is the wing of a housefly. Or I know that 1 gram is 1 paperclip. So if I took a paperclip and cut it into 1,000 pieces and took one of those, that would be a milligram. So it's really small. A kilogram is a pair of shoes. So it's about 2 pounds, 2 and a little bit. And a metric ton is also a small car. So there's a little bit of difference here, but not a whole lot. So, got the idea? We'll put that over here just in case we need it. Okay, so example 1. Oops, let me find I never find the right one. A large elephant weighs about 4 tons. How many pounds does that large elephant weigh? So if I look over here on my chart, and they didn't say metric tons, and they're talking about pounds, so I know I'm going to use the U.S. customary system. I know that 1 ton is 2,000 pounds. So 4 tons, 1 ton times 4 is 4 tons. So 2,000 times 4 is 8,000 pounds, right? So the elephant weighs about 8,000 pounds. Wow. Isn't that crazy? Think about the small car weighs 1 ton, and the elephant weighs 4 of those. That's crazy. All right, example 2 says Boyd's watermelon had a mass of 6 kilograms. The mass of the watermelon was how many grams? So 6 kilograms equals how many grams? Let's come over here and look at my chart, and I know that 1,000 grams is 1 kilogram. So 1 kilogram is 1,000 grams. So if I multiply that times 6 to get 6 kilograms, I multiply that times 6, and I get 6,000 grams. I didn't talk very much about mass and weight. So this is a total aside. You can fast forward through it if you want. Weight is a measure of how much gravity pulls on you. Mass is a measure of how much stuff is inside of you. So if I go to the moon, my weight is going to change. I would be like slender and lovely and a ballerina on the moon. But my mass would not change. I didn't cut off an arm or a leg to lose that weight. I still have all the same parts and pieces, but because gravity on the moon is less, my weight changes. So mass doesn't change, weight does. depending on what planet you are. So if you're all talking about planet Earth, it's not quite as important to think about the distinction. But if you're going to Mars, which I hope we're doing soon, then that might start to matter a little bit. All right, example 3. Antoine works at a sandwich shop and uses 2 ounces of cheese for 1 sandwich. If he makes 16 sandwiches, how many pounds of cheese does he use? So, what are they asking me to find? Pounds? They gave me ounces and they gave me sandwiches, but they want to know pounds? So it looks like I'm going to have to find ounces first, right? So this is a 2-step problem. So if I have 16 sandwiches and I use 2 ounces on each, I'm going to use 32 ounces, right? All right, so I come over here and I know that 1 pound is 16 ounces. And so 2 pounds would also be 32 ounces. So 32 ounces is 2 pounds, right? So that one sounded trickier than it was. It was definitely a couple of steps. Sometimes it helps me if I highlight kind of different pieces of the word problem or underline. Sometimes you can circle one and underline one. I know Mrs. Cador and Mrs. Rustin may have told you a little bit more about what they want from a word problem. Mrs. Snyder will too. But be sure to pick out the important parts before you do a 2-step problem, okay? All right, let's look at example 4. Mr. Harrison's truck has a capacity of a half of a metric ton. So he wants to know if these 3 containers he had will overload his truck. So he has 156 kilograms, 127 kilograms, and 149 kilograms. So all he wants to know is he going to be overloaded? He wants to know if he added those up, is it going to be more or less than a half a metric ton? So since these are measured in kilograms, and he's talking about tons, I have to either change these to tons or change this to kilograms. Since I only have a part of a ton, let's change that one to kilograms, okay? So I know that 1 metric ton is 1,000 kilograms. So a half of that, a half a ton, is 500 kilograms. So his truck can hold 500 kilograms, right? All right, so I can add it up. But do I really need to? I don't really need to know exactly how much that stuff weighs. What I really need to know is it less than 500? So let's round it. So I'm going to say 156 rounds to 150. And I'm going to use the tens place here because I want to be pretty accurate. I don't want to just round this down to 200 to 100 and to 100. I want to be a little more accurate than that. So I'm going to round to the nearest tens place. So I'm going to mark my place, look next door. Is that 5 or greater? Yes, so I'm going to add one more to that. So that rounds to, should round to 160. Did I put 150? Oh, you know what I was doing? I wasn't doing that. Sorry, I did this last night. I was rounding to easy to add numbers. So I was rounding to the nearest 50ths or 25ths or 75s. You could do it that way, and we'll go ahead and do that. We'll leave that there just in case. So that one's going to round to 130, and that one's going to round to 150, and we'll see what we get. 440. If we do it this way, it rounds to 425. That's easy to add in your head. Remember how I said that estimation is a little fuzzy? There's not one particular best way to do it necessarily. There really is, because you can come pretty close. So if I actually added it, I get 432. When I round to easy to add compatible numbers, I get 425. When I round to the nearest tens, I get 440. It doesn't matter, because guess what? He can carry that because they're all under 500, right? If there was some question, I might need to be a little bit more careful about how I added it. So we find out that Mr. Harrison is in luck, and he can put all those 3 containers in his truck. Okay, good luck with this.